Okay, so the next variable that I want to do is the education variable. And let me save this. I have an asterisk up here. So what about my education variable? So here's the education variable, DMD EDUC2, and this is the education level in adults 20 and above. And you can see that 1, 2, 3, 4, 5 are increasing levels of education. But in this one, we have something different. We have, not only do we have missing values that are coded as a dot, but we also have 7s and 9s that actually indicate either the individual refused to answer the question, or the 9s, they said that they don't know. I'm actually interested to see how many 7s and 9s we have. So let me go over here and look at that. So data, work data, set work data, proc, frequency tables, and what was the variable name? There it is, right here. I'll just copy and paste it. And let's just run this and see what it looks like. How many 7s and 9s do we have? So very few. We only have 6 7s and 10 9s. So I'm just gonna remove those from the data set. And the way I'm going to do that is I'm going to recode them. I'm going to recode them as missing. There are already 16 missing 16 individuals who have missing education data. So we'll add another 16 to that. That's not very many. So what I'm going to do here is, I'm already in SAS. I want to go over here. So what I'm going to do first is, and let me comment this out. I'm going to say if this variable is equal to 7 or 9. Now, if you have a logic structure that includes more than one condition, there's a way you can do it. You could write, does this equal 7? If it equals 7, then make it missing, and then make a second line that says, if it equals 9, make it missing. But you can make your code a little more efficient by using what's called in, and then that's followed by parentheses. And what you can do is you can say, if you can list the values within the parentheses, that if any of them are true, then you consider the whole statement true. And so SAS will continue and do the code that you tell it to do after that, after the then statement, the if then statement. So here, what is it? We want to know if it's either equal to 7 or is equal to 9, I want to recode that as missing. So what I can say here is I can say if the education value is in 7 or 9, then the education value equals, and if you want to recode something to missing, you can actually put a dot. That will recode it as missing, and then semicolon here. So then let's go ahead and let's use this one. Let's see if it changes our changes the values. We had 16 missing before. We want to recode 16 more as missing. Let's see if it comes out right. And notice that I have the if-then statement is before the procedure, so this should be fine. The order is correct. And so now you can see that we have 32 missing. So those 16 that were in the 7s and 9s have now gone into the missing, and now we have education 1 through 5. Now let's go back and look at what the education values actually mean. So here we have value 1 is less than 9th grade, and value 2 is 9th to 11th grade. 3 is a high school graduate. So 3 starts with high school graduation, and these two levels are less than high school graduation. I'm thinking that this is maybe more levels of education that I need, that possibly, less than 9th grade and 9th to 11th grade, that these could be considered one level of education, which is basically, less than high school. So my first level of my variable will be less than high school. Second level would be high school grad, GED, or equivalent. The third level would be some college or an associate degree. And then the fourth level would be college grad or above. So what I want to do is I want to create an education variable with 4 levels. And what I'm going to do is I'm going to code these two as zeros. And then this is going to be 1, and then 2, and then 3. That's how I want to create my variable. And so let's do that now. So I'm going to, what I'm going to do is I'm going to comment this stuff out again. And what I'm going to put it up here at the beginning just to sort of remember what we did. And then, so what I want to do is I can use the same kind of code that I used before. If I say, if this value is in 1 or 2, because remember what I'm doing here is I'm going to be, if it's either 1 or it's 2, then I'm going to code it as a 0. And I'm going to have an education variable that has 4 levels, 0, 1, 2, and 3. So I'm going to call the variable education 4. So if this is true, the education value is either 1 or 2, then I want to create a new variable called education 4, and I want to give this a value of 0. And then after that, I don't have to use this in anymore, because now what I'm doing is I only have one level. So if it's equal to 3, I want to change it to a 1. So let me do that. So if this equals 3, and I like to keep these sort of lined up, then education 4 is going to equal to 1. And now what I can do is the remaining, what I have is I have to do 4 and I have to do 5. The code's going to be similar, so I'm just going to first copy and paste. So copy, paste, I have 2. So this is going to be 4s, this is going to be 5s, and then this is going to be equal to 2, and this is equal to 3. So this should recode what I want to do. It's first going to go through, it's going to get rid of those 7s and 9s, make them missings, and then all the 1s and 2s are going to become 0, 3s will become 1s, 4s will become 2s, and 5s will become 3s. So let's do a proc frequency tables. And what do I want to do here? I want to look at the original education variable crossed with my new education variable, and I want to use the slash list, and let's see if this comes out to be what I want. So here you can see the ones I still have, I've recoded those 16 to missing, the 7s and 9s. 1s or 2s now are 0, 3s are 1s, 4s are 2s, and 5s are 3s. So everything came out right. So it's really important to check to make sure your recodes are correct each time, because it's really easy to make a mistake. Okay, so education is done. Let's get rid of this, and I have an extra run statement down here that I don't need. Okay, let's take a closer look at what this code does here. And so here, let's draw it out again. So what do we have here? So we have the sequence and 1 through 6. Let's just put these. These represent the different people. And then we have the education variable. We have values between 1 and 5. We also have 7s and 9s and some missing values. So in this first line of code, it says if the value is either 7 or 9, then change the value to a dot. And so we have 2 of them that are 7s or 9s. And so in this first line of code, what's going to happen is that when it gets to this line, it's going to say, okay, this variable is within 7 or 9. It's a 7. And so I'm going to do what's after the then statement. And it says that now the variable equals missing. So it's actually going to erase that value, and it's going to change it to missing. And the same thing is going to happen for the 9. So this is what happens after the first line of code. Now, you know, it's not actually doing the first line of code and going through the data set. It's actually doing something else. It's going to, it's going through the data line by line, and for the first row of data, it's running all of these. But in the first row of data, the first line of code does nothing. So I've just sort of shown that at each data step, each row of data, what happens with the first line of code. So down here, after it runs the first line of code, it continues on, right? And so it looks for if the value now is within 1 or 2 in this row of the code, 3, 4, or 5. And since it doesn't find anything true, this is equal to missing. It'll never do anything else. But we could, below this, if we put another line of code in here that says if the value is equal to missing, do something. Well, for that row of data, it would actually take action on 2 lines of code. It would first change it to missing, and then if later on we said if the education is equal to missing, do something, it would do it at that step. So it starts at the top and works its way down. But here we don't tell it to do anything with missing data, so these missing data aren't going to change. But what will change are these other ones. So basically it says if the, for this first one, the education value is equal to 3. So it's going to run this line of code, and it's going to create a new variable education4 and give it a value of 1. And for this row of data, the value is equal to 5, so it's going to be running this line, which is going to give it a value of 3. And this one, this is missing, so nothing is going to happen. Nothing is going to get written here, so this is actually going to be a missing value. If nothing gets written, it starts out as a missing value, and it stays as a missing value. And then for this one, it's a value of 2, so it's its first line. It's in 1 or 2. It is 2, so this is going to get a value of 0. So this is how this code is going to run inside the working data. So the next variable that I want to do is the income variable. So let me put a comment here. This is going to be income. Oops. Data, work data, set work data. And oops, I have a misspelling there. And let's go look at the income information. So there were a couple of income variables. One was this one here, the annual family income, but it's coded strangely. There's lots of levels, and they have this greater than 20,000 and less than 20,000, which is a different level of fidelity to the data than up here. And then they have these categories up here, and then greater than 100,000. It's a little bit strange, and so I think what I'm going to do is I'm going to use the this one, the ratio of family income to poverty. And this one is actually a number. It's continuous, but the one thing about it is that the highest value is 5. And so anybody who had a value greater than 5 was coded as 5. So the quality of the information is a little bit different. Below 5, it's continuous. Above 5 is kind of like categorical. It's one category for everybody who's above 5. So I think what I'm going to do first is I'm just going to look at the distribution of this variable. So let me grab the name of it. And I'm going to use, it's a continuous variable. So I'm going to use proc_univariate. Put the variable name, and then I'm going to get a histogram so that I can sort of see what it looks like. Now let's see what this is like. So you can see here the 5s. There are lots of 5s. This information down here is actually continuous. It goes from 0 to 4.8, all the way up to 5, really. So this is a situation where you might actually want to make a continuous variable into a categorical variable, because across the distribution of the variable, you've got different kinds of data. You've got categorical information essentially up here, because you've lost all of the information about the exact, in a continuous way, measure of the family income to poverty ratio. And so I think what I'm going to do is I'm actually going to make this into 3 levels. I'm going to use this 5 and above. I'm going to use this as 1 level. And then what I'm going to do is I'm going to take all of the people below 5, and I'm just going to cut them essentially in half by sample size. So what I'm going to do is I'm going to teach you a procedure in SAS that can cut up data, continuous variable, into as many groups as you want by the rank. So what I'm going to do is I will comment this out so that it's still here. But I'm not going to put the run here. I'll use that down there. So the procedure is called procrank. But before we can use it, we actually need to subset the data to only those who are below 5. Because if I use procrank on the entire data set, it's going to include these above 5 when it's calculating the number of individuals within each group. And what I want is actually just for those who are below 5, I want to split those individuals into 2 equal groups. So the first thing I'm going to do is I'm going to create another data set in the temporary working memory that only includes those individuals who are below 5. So I'm going to actually start a new data set. I'm going to call this temp for temporary because I'm only going to use it for a little while. Then I'm going to merge it back into the original data. So I'm going to use work data, but what's going to happen here now is it's going to take that data in work data and it's going to put it into the working memory again, but give it a different name. So I'm going to have two temporary I'm going to have two data sets in the temporary memory. And here what I want is I want only those individuals whose family income to poverty ratio is less than 5. Let's just run this and see what happens. Make sure the sample size goes down as we expect. So it's going from 10,000 to about 11,000 down to about 9,000. So that means there should be about, 1,800 individuals here? Oh, it's percentages, so I can't tell. So what I've got, that's about 18%. Do I have about 10,000 people? Yeah, so I have about 10. So it looks about right. So that is reduced. So now what I've got in the working memory under temp, I've got all those individuals who have family income to poverty ratios less than 5. So I'm going to use a procedure called procrank. And what procrank does is it creates categorical groups out of a continuous variable. So what I want to do here is I want to create 2 groups out of this distribution from low to high. And I want to put the half that are lower in one group and the half that are higher in another group. And so procrank, the next command is groups equals, and you can see that it turned blue. And here you tell it how many categories you want to create. I want to create 2 categories. So I'm going to say 2 and then a semicolon. Now the thing you have to do is you have to tell it first, what variable are you going to use to create your groups? And so the variable or the command is var, and the variable we're going to use is the family income to poverty ratio, which is, this is the name of it. So I tell it that's the variable I want to use, and I put a semicolon, and then it's going to create a rank variable, and we have to tell it what to call that. So this is called ranks, and we're going to let's just call it income rank. You can give it any name you want. I'm just going to call it income rank. And then we need a run statement. Now, one of the things you also need here is, for this one, you need to tell it that once it creates the ranks, where should it save that? And it doesn't save it automatically into the temp. So you can put this here. You say out equals temp, and you see it turned green, or blue rather. And so this should run. Let's give it a try here. And what it's going to do is it's going to create a new variable called income rank. And it's going to have 2 levels defined here, defined by, it's basically going to take all the individuals who are in the data set, and it's going to take this variable and it's going to put the lower half on this variable into one group and the upper half on this variable into another group. So let's just see how this runs. Everything is blue. We now have 1 extra variable. We have 30 variables now. That's from where the variable income rank was created. So let's just do a proc frequency and see what it looks like. Proc frequency, tables, income rank. Let's see how it did it. As you can see it down here, income rank has 2 levels, 0 and 1. 0 are the lower half, 1 are the upper half. You can see the sample sizes here are almost the same. It's almost 50-50. The reason it's not exactly 50-50 is because it won't put individuals who have the same value on the family income to poverty ratio into two different groups. And so it finds a natural split as close to 50-50 as it can. So it looks like it's worked correctly. So what we'll see here is we actually have among this data, we have 1,000 individuals who have missing data. So we're going to lose about 1,000 out of 11,000 here, probably like 9% or so. So, this is a fairly large amount of missing data. Oftentimes, I kind of use a target of or a guideline of about 10%. If there's more than 10% missing data, then maybe it's not a good variable to use. This one's just under that. There are ways that you can recode missing data. That's called imputation. Imputation methods are beyond the scope of this course. What we're going to do is we're just going to exclude those individuals who have missing data. And this might induce a little bit of selection bias into our model. It depends. It depends on if the association between our cause and our outcome is different among those individuals who we have data for compared to those individuals for whom we don't have data. We don't really have a way of knowing that directly because we don't have the data to check it. But we know that there's a potential here for selection bias creeping into our model whenever we have these high levels of missing data. But we're just going to go with it here. And so what I have now is I have this income rank variable in the temp data. And what I want to do is I actually want to merge this back into the working data set. And so what I need to do is I need to create a data set that only has the sequence number that I can use to merge it, and also the variable that I want to put into the working data. And so what I'm going to do is I'm just going to use data temp. So I'm going to call temp. I'm going to basically just limit it to the variables that I want. I want to say keep. I want to keep the sequence, and I want to keep the income rank variable. And since I'm going to merge this, I'm going to sort it on the variable by which I want to merge it. And so we do it like that. So this one I think I can put up here so you can see it. And then I will comment it out. Now, why did I use a new data temp set temp statement? It's because I can't use this keep statement after I've run a procedure. So if I was to, try to do this, put this in here and start it, it's going to give me an error. You can already see that it's red. It already knows it's an error. So after the procedure, I can't use keep statements. So I had to start a new data step here. And so that's what I did. So we've already got the rank. So I'm going to go ahead and do this one. I should have two variables. Yep, I got two variables. And so what I can do now is I can take the data, work data, set work data, and I can sort it by the sequence, getting it ready for the merge. Let's make sure that ran okay. Looks fine. So now what I'm going to do is I'm going to merge this temp data set into the working data. So I'm going to say data work data, and I'm going to merge. I'm going to take the work data and merge it together with temp by the sequence. And if we run this, this should give us, so it has 10,989 in work data. There's 9261 in the temp. That's right, because we limited that. We don't have the people with 5s and above. And we have, in the final one, we have 1,989 because that's the original amount or a number of people in the work data. And now we have 30 variables there. So now I've got the information inside work data that I need to use to create my income variable. So let me just start data work data, set work data. And so what I'm going to do is I'm going to create a variable called income3. I'm going to have 3 levels. And I'm going to say if income rank is equal to 0, remember this is the bottom half of those below 5, then income 3 is going to be equal to 0. And then I'm going to say if income rank is equal to 1, then income 3 is equal to 1. Now, what I want is I want all those individuals who have a value above 5 or above to be the third level of income 3. So I'm going to say if, I can just copy and paste it from up here. But actually, this is not less than. This is if it's greater than or equal to 5, then income 3 is going to be equal to 2. So this should give me what I want. Okay, so it looks like it ran okay. Okay, now I want to check to see if this coded correctly. And so what I can do is I can actually use proc means and look at the mean values within levels of my 3 variables. The way to do that is to use proc means with a by statement. We haven't done that yet, but I'll show you how to do it. What we want to do is we want to do proc means, and then we're going to say by, and we're going to do basically 3 different proc means within levels of a categorical variable. So I want to use income 3 as that variable. I'll do proc means within 3 levels. And then the variable that I want to do is I want to look at the original value of the family income to poverty ratio. Now, I'll show you in a moment what this does. Before we can do this though, when we use a by statement, we have to sort on the variable by which we want to use the by statement. So here we have to actually do a proc sort by income 3. And so what it's going to do is it's going to sort the working data by income 3, and then it's going to do proc means within 3 levels of income 3 and give us the mean value of this variable within each level of income 3. But one of the things that proc means also does is it gives you the minimum and maximum value, so we'll be able to see if this coded correctly. So let's try this. So here we have proc means. So income 3, if the income is missing, then basically there's no value of the family income to poverty ratio. That's true. If we didn't have data, that's why this variable would be missing. Let's look at this though. So basically for income 3, if the level is equal to 0, there are 4,106 people there. The minimum value is 0 to 1.62. And then in the next level, it goes from 1.63 to 4.99. So you can see that from 0 to 4.99 has been split into 2 equal groups. And then within income 3 equals 2, the minimum and maximum values are the same because everybody has a value of 5. And there are 1,728 people there. Now you'll notice that within income 3, the number of people in each group is different. Well, that's okay. What we're worried about is if there's too few people in any one group. And if we had that, we might consider collapsing some categories together. But this is fine. We have our smallest group is over 1,700. And that's more than we need. So we have now income 3 coded. Okay, so let me just take out this using a comment.